Hello everyone, I'm Jay Joshi and welcome to the 24th episode of Learning Java. Today, we'll be learning about function overloading. So in my previous video, I covered what functions are. So let's have a quick recall. So function can be declared in the class but not in the main, and these functions can be called, these static functions can be called inside the main method. So this is the piece of code I wrote in my previous video, and I'm using this for reference to explain what function overloading is. So as I mentioned, this specifies the access. It can be public or private. This is either static or non-static. This is the return type. This is the name of the function, and this is the parameter. Now, what is function overloading? So function overloading is a feature in Java in which we can have two or more functions having the same name. So yesterday I said that you can have multiple functions in the same class with different names, so, performing different functions of different parameters, return types, etc. So you can have multiple functions of different names. Now let's say you're writing a very big code with lots of functions. It'll become very confusing for the programmer to use, let's say, 100 different types of functions. It'll become difficult for him to remember the names of so many functions. So that's why there's a feature called function overloading, which is a part of a thing called polymorphism, which allows us to have multiple functions of the same name having different parameters. So let's see what this actually looks like in working. So over here, I'm calling a function. The name of the function is fun, which is returning an integer type, and it has a parameter, one parameter, which is integer. And I'm calling this function in the main method as fun a, which is a value entered by the user. Now I can also call the same function. Let's say I call the same function again. I can call the same function twice, right? Now let's say I want to perform another function in which I multiply. So in this case, this is the square of an integer, this fun function. But let's say I want to perform a function to find out the square of a double number, of a number with a decimal. How do I do that? Well, for that, I'll have to write a new function. So let's say I write a new function, public static int. So this will, since the return type will be double because I'm squaring a double number, it'll be double. And let's say I call this function fun1. The parameter is double m, and this piece of code will be the same. So I'm just squaring the number and then returning that particular double. And over here, I'm calling function fun1. And this code will work, no problem. But let's say I have now so many functions like this: fun, fun1, fun2, fun3, fun4, goes to fun100. So it'll be a bit confusing. So what we can do over here is that since this is performing a similar function, it's not the same function, it's the similar function because this is integer and this is double. Instead of having functions of two different names, we can just have the name as fun. And this code will still work. Now let me explain what's happening. This is one function, fun. There are basically two types of this one function, which is fun. So there is one main function called fun, and then we are dividing it into two parts. So this is one part of the fun function, this is another part. And both of these functions, which have the same name, have different parameters. Now this is the most important part of function overloading. So the main thing is how does the programmer differentiate between this function and this function? So over here, I'll have to put another line of code. So this will be double d is equal to sc dot next double. Now over here, and I call d over here. Now how is this working? So when this function a is called, it calls the function fun. So there are two functions who have the name fun. So which function does it call? Then it looks at the parameters. So since this parameter is a, so and this is an integer, a is an integer, it'll look for function fun which has the parameter integer, and there's only one parameter in that same order. So as I mentioned last time, there are three things you check in parameters: the order of the parameters. So let's say there are like 5 parameters in double string. So the order matters. It shouldn't be string double int. It should be int string double, whatever the order you want. The order, the data type. So if it's int in this case and it's double in this case, and the number of parameters. So let's say this has one. Let's say there's a function with 3 parameters. So since this a is integer, it'll call the function fun which has integer as a parameter. So over here we have integer as a parameter, so we'll call this function. In this case, when function d is called, d is double. So it won't call this function because the parameter isn't a double, it's an integer. Instead, it calls this function in which the parameter is a double. Now we can have something like, let's say I'm calling a function a comma d, and I can have something like int a comma double m. This is also possible. So in this case, again, it's differentiating because this is int, this is double, and this is int, this is double. So it's calling that. So as I said, the number of parameters, the order of parameters, and the type of parameters. So that's how Java internally differentiates between functions. Now, let's say it doesn't find a function. Let's say I have something like this. If I put this as long and c dot next long, then what will the compiler do? Yeah, it's giving an error right here. So you cannot, the compiler will throw an error. It can either be a runtime or compilation error. Right now it's compilation because there is no parameter a long because this is all int and this is int a. So if I put this as long, then we have to even change the return type over here. So long, and even here as well. So this code will work because long and this long is matching. So as I said, the data type should match. Now let's say if I'm calling a function, so then, and if a particular thing doesn't exist, for example, there's a long over here, and let's say we have something like d. So over here we are calling two functions, function a, function d, and both of them are fun, so it's function overloading because they have the same name. This, when I call this function, it'll be no problem because there is a function fun which has the same parameter as this. But over here it will not be called because this is double, and over here there's not a single function fun which has the parameter, which has a single parameter in that particular order with the data type double. So it will not call any of these because, and it'll just throw an error right now. It's throwing a compilation error because there's no particular match found, right? And it tries to convert. Now, let me explain the next part of function overloading. So now you currently know that function overloading is functions, multiple functions having the same name, and the compiler differentiates it based on the order, type, and the number of parameters. Now, let's say I have something like this. Let's say this doesn't exist, and I have one function, and I remove this as well. And over here, this is integer, and let's say I have something like this. So you might remember I taught a couple of episodes ago about type conversion. So there are two types of type conversions: implicit type conversion and explicit type conversion. Implicit type conversion means conversion from a smaller data type to a larger data type, so which is dependent on the byte size. So let's say we convert integer to long, byte to long, float to double, or anything else, character to integer. This is implicit, which is done automatically by the compiler. And explicit type conversion means conversion of a higher data type to a lower data type. So conversion of long to int, or int to byte, or double to float. So this explicit type conversion is done explicitly by the user and it's not done by the computer itself. So now we need to know that in function overloading, there is implicit type conversion as well. So over here, this is an integer a, and I'm calling the function fun a. And you can see the compiler isn't throwing an error when I compile it. Why? Because what it does is, if no particular match is found, so first, since it calls the function a, it checks if there's function fun, which has an integer parameter, only an integer parameter, and it checks, and no, there's none. So then what it tries to do, it tries implicit type conversion. So it tries to convert this data type, whatever this data type is, the calling data type, into this actual parameter. So this is the calling parameter, this is the actual parameter, because you're calling it over here, and so that's why this is the calling parameter, and over here this is the actual parameter. So it tries to convert the calling parameter to the actual parameter implicitly. So since integer is smaller than long, the type conversion works and we actually get what we want. So this a integer, let's say the user enters the number 20, this integer 20 gets converted into long when it goes to this function. So, so this is the important thing to note over here, is that in function overloading, if no particular match is found based on the parameters, the computer does implicit type conversion. And if it doesn't find implicit type conversion, then the compiler throws an error, as I had shown before. So this is what function loading is. The main function is to make the code easier, more compact, and mainly easier for the people who are reading the code and the person who's writing to not get more confused. We can have multiple functions. We can have n number of functions, fun, with different kinds of parameters. So this is something very useful in function overloading. So that's it for today, everyone. Thanks for watching. And if you have any queries, doubts, or suggestions, you can mail me. My email will be in the description down below. And thanks again for watching.